Okay, now common factors can be expressions. If an algebraic expression has 4 terms and no common factor in all of the terms, we may be able to group the terms in pairs and find a common factor in each pair. Let's look at worked example 20 and 21. With worked example 20a, we have 2 terms, 5x plus y plus 6b x plus y. So we have 2 terms. In each of those terms, each of the terms has x plus y in the brackets. So this is the highest common factor, or the common term to those 2 expressions. So what we do here is we take our highest common factor out the front. Then, in our brackets, with our first term, we say 5x plus y. What are we left with if we have divided that by x plus y? Well, we're left with 5. And in our second term, we have 6b, x plus y. We're going to divide that second term by x plus y. And what are we left with? We're left with 6b. So we have just factorised that expression. Let's look at b. We have 2b, a subtract 3b, and then we're subtracting a subtract 3b. So again, we've got 2 terms. Both of those terms have a subtract 3b in brackets. So what we do is we take that out as our common factor, and then we look at our first term and we say 2b, a subtract 3b. When we divide it by the term we've taken out, a subtract 3b, we are left with 2b. Then we get our second term, negative a subtract 3b. Here's our second term, and we're going to divide it by the term we've taken out, a subtract 3b, and we are left with negative 1. Okay, in worked example 21, we do an extra step is involved. So in 21a, we have got 4 terms. I'll read out what I read out earlier. If an algebraic expression has 4 terms and there's no common factor in all of those terms, so in this case there is no common factor to those 4 terms, it may be possible to group the terms in pairs and find a common factor. So let's look at the first 2 terms. 1, 2. Is there something common there? Yep, 5 goes into them both. So I take 5 out as my common factor and I'm left with a plus 2b. Let's look at my second 2 terms. They both have positive c. And then I'm left with a here and 2b here. We now have 2 terms, and just like in worked example 20, in those 2 terms, both of these terms have a plus 2b in brackets. So we take our a plus 2b out as the common factor, and then we get our first term and we say 5a plus 2b. What are we left with if we divide that by a plus 2b? Well, we're left with 5. And with our second term, if we have positive c, a plus 2b, and we divide that by a plus 2b, we are left with positive c. Worked example 21b. X subtract 3y plus ax subtract 3ay. Again, 4 terms, nothing common to them all. Alright, let's look at the first 2 terms. What is common to those first 2? Doesn't look like anything's common, but remember, 1 is always common. So 1 is common, and we're left with x subtract 3y. Let's look at our next 2 terms. They both have an a. So I'm going to take out a positive a, and I'm left with x subtract 3y. Now we've got 2 terms. Let's look what's in the brackets. What's in the brackets of each of those terms is the same thing. X subtract 3y. And if I have taken the x subtract 3y out from the first term, I'm left with 1. And if I've taken the x subtract 3y out the front of the second term, I'm left with plus a. Okay, Worked example 21C is 5p plus 6q plus 15pq plus 2. Alright, let's look. 4 terms, nothing common to all 4 terms. Okay, this is an example of where I might have to rearrange the terms to find terms that are common to the first 2 and the last 2 terms. So I'm going to rearrange the order of these, and I'm going to write it as 5p plus 15pq plus 6q plus 2. Now the reason I did that is I couldn't find anything common to these first 2 terms or to the last 2 terms. But by rearranging I can. Let's look at the first 2 terms. They both are divisible by 5 and they both have a p. So these 2 terms, if I've taken 5p out the front, I'm left with 5p divided by 5p is 1, and 15pq divided by 5p is plus 3q. Let's look at the last 2 terms. What's common to those? They've both got a positive 2. And what am I left with? Well, if I've got 6q and I divide it by 2, I'm left with 3q. And if I've got 2 divided by 2, I'm left with 1. Okay, we've got 2 terms left. I'm going to highlight what's in the brackets, because what's in the brackets of these 2 terms is in fact the same. 1 plus 3q and 3q plus 1 is the same. The order is different, but that doesn't matter. So I'm going to take my aqua highlighted thing out because it's common to both terms, 1 plus 3q. And if I get my first term and I divide it by 1 plus 3q, the 1 plus 3q cancels out and I'm left with 5p. And if I get my second term and divide it by 1 plus 3q, the 1 plus 3q or 3q plus 1 cancels out and I'm left with 2. So what this video has looked at is grouping 2 and 2. Remember, if an algebraic expression has 4 terms and no common factor is found in all 4 terms, it may be possible to group the terms in pairs and find a common factor in each pair.